some of your friends will want to take advantage of the ignorance of others. So one of the things you're supposed to do, even as you're in campus or before you leave campus, if you have not done it yet, you need to change the password to your Moodle. Because when you're first given access to Moodle, I think it's your username, your computer number and stuff, that's what your username is, and your password is your computer number. So what we experienced last year, because we had very few questions, was that some students, and it also happened yesterday, some students with very bad motives, they got into other students' accounts, then they attempted the quiz on behalf of the other student so that they could see the questions. Okay? When the owner of the account logs in, they find that the quiz has already been attempted for them. So these guys don't even bother to answer anything. They just want to see the questions. Are we clear? So the first thing you're supposed to do so that you're able to answer the quiz at any time is that you need to change your password. Change your password from your computer number to anything else. And do not share your password with anyone. It doesn't matter whether it's your boyfriend or it's your girlfriend. Do not share your password with anyone. Because those people who attempt the quiz on your behalf, you end up with a 0, they'll get better results. Then you come and complain to us and we'll tell you there's nothing we can do about that. Are we clear? So change the password of your Moodle and do not share it with anyone. You should be the only person logging into your Moodle. Don't ask your friends to log into your Moodle on your behalf. When it comes for time for quizzes, they will try to do things on your behalf so that they can have an advantage. Are we clear? The other thing is that since we started this process of online quizzes last year we had much fewer questions. This time around, we are adding more questions to the quizzes. So for each quiz, our ideal situation, we want to reach a situation whereby each quiz probably has 50 questions, but you only get to answer 10 of them. So the computer will choose 10 questions for you to answer, and everybody is answering different questions. We want to avoid a situation whereby people screenshot their screens and send them to their friends so that those friends can answer the questions later. Everyone is going to receive different questions, but you're only going to receive 10. So you don't know which questions you're going to receive. So those people who tried to attempt the quiz on other people's behalf, yeah, you'll see some questions if you did that. But the questions you're going to receive yourself are not the same questions as the other person received. So you are going to receive 10 random questions. Are we clear? So it won't be, very soon, it will not pay. At a point we're going to reach so many questions, it won't pay for you to get into other people's accounts. And the moment you get found out, this time around, if you get found out, it's direct expulsion. So your career as a university student at the University of Zambia will come to an end immediately. Because getting into someone's account, then doing things, pretending to be them, impersonating that person, is a crime. And most likely you risk going to jail. Not just being expelled from the university, but you also risk going to jail. So it's not worth it. Do not try to get into other people's accounts. You have got your own account, get into it, then attempt the quiz. And usually we encourage people to attempt the quiz as early as possible. Then forget about it. If you have not shared your account password, then you can try to attempt the quiz at any point during the day. And also, if you have changed your password, the other thing is you need to change your password. Are we clear? Please share the message. Change the password. Last year, students, parents, a student would complain, oh, someone has attempted the quiz on my behalf. Then the parents would call us. There is nothing we could do. Okay, so please, the first thing is you need to change the password to your Moodle. Once you change the password to your Moodle, do not share the password with anyone. Do not share it with anyone. Okay? You're going to do your tests. These quizzes, most likely also your tests. You're going to do your tests online. The only thing you're going to do physically is when you come and write your final exam. That being the case, you need. You're going to do. You are going to do the way you're doing your quizzes online. The tests also will have to be done online. Test 1, test 2. When you write test 1, test 2, you have to do it online. Probably it's going to be a bunch of 100 questions you have to answer. Most likely, again, multiple choice things. Okay? So access to your Moodle should only be restricted to you. If you don't change your password, if you share your password with other people, then they write the test on your behalf. They look at the questions. The worst part is they will look at the questions. They won't even try anything. They just want to look at the questions so that they have an advantage. So you end up getting 0. Then later on you call us and say, oh, someone got into my Moodle. We ask you, did you change the password? No. Did you change the password? Yes. But you shared with other people? Yes. There's nothing you can do. Are we clear? So please, all of you need to change your passwords. And after you change your passwords to something you can remember, or you can write it down somewhere, I don't really care very much. Don't share it with anyone. Okay, let's see what we have. I think we're supposed to finish something in our case. Yeah, so many holidays. We haven't really done much, but let's make progress. Okay, so we are supposed to, I think, look at how to. We introduced this bit where we had vectors A with a size with displacement of 20 meters at an angle of 45 degrees, vector B displacement of 30 meters at an angle of 120 degrees, vector C size of 10 meters at an angle of 180 degrees. So we are supposed to carry out additions and subtractions of these 3 vectors so that we can see how that is done. So for each of these vectors, A, B, and C, the first thing we're supposed to do is we're supposed to come up with a table called a table of components. We showed something like this, but the table we're interested in is this one here. We're supposed to come up with this called a table of components, where you, for each vector, the name of the vector, then you've got the x component. The x component is how much that particular vector is along the x direction, because the only directions we are interested in is how much a vector is along the x-axis and how much a vector is along the y-axis. So how much a vector is along the x-axis, that's what we call the x component, and the y component, how much is the vector, what's the size of the vector along the y-axis, that is what is called the y component. So for each vector, when it comes to adding vectors, okay, when it comes to adding vectors, you need to find these components. These components are special vectors whose directions we know. For an x component, we know that this vector is pointing along the x-axis. For a y component, we know that this particular vector is pointing along the along the y-axis. Yeah, that's for the y-axis. So in the case of vector A, we know that vector A has got a size of 20 meters and it makes an angle of 45 degrees. With this information, the size of the vector A and the angle, we can find out how much vector A is along the x-axis. And that's how we write this. AX, the x component of vector A. And how do we do that? We multiply the size of the vector, which is 20 meters, multiplied by the cosine of the angle the vector makes with the x-axis. So the angle the vector A makes with the x-axis, that angle is 45 degrees, as you can see from this diagram here. So the vector is this one in black. This is 20 meters. Then the angle it makes with the x-axis is the 45 degrees. So you are always going to multiply. When you're working out the x component, you always multiply the size of the vector multiplied by the angle from the vector and the x-axis, between the angle between the vector and the x-axis. So when you do that, you get 14 meters. That's what you get. So in this case, the size of the vector is 20 meters and the x component of the vector is 14 meters. Okay, next, so the one thing I want to point out here, as you can see, this 14 meters is less than the 20 meters. So usually, one of the things which happen when you're working out the components of a vector is that you find that the component is going to be less than the vector, or it's going to be equals to the size of the vector. One of two things will happen. Usually the component is usually less than the vector, or it's equals to the vector. So in this case, our component is 14 meters, which is less than 20 meters. Then we find out how much vector A is along the y-axis. So that's going to be 20 meters multiplied by sine 45 degrees. So when you're working out the y component, you multiply the size of the vector times the sine of the angle between the vector and the x-axis. And in this case, the y component is 14 meters as well. It's 14 meters here, positive 14 meters, and here it's positive 14 meters, because when it's positive, it's pointing in this direction. It's pointing along the positive x direction. A component which is positive, in this case positive x, y component, for x component, if it's positive, it's pointing along the positive x direction. For the y component, if it's positive, then it's pointing along this direction. It's pointing in this direction, along the positive y direction. If the x component is positive, it's pointing along this direction. If it's negative, then it points along this direction. Then if it's the y component is negative, it points along this direction. Are we clear on how we work out a component? Are we clear on how we work out the components of vector A? Okay, then we move on to vector B. For vector B, we need to find out how much vector B is along the x-axis and how much vector B is along the y-axis. How much vector B is along the x-axis, that is what is called the x component of vector B. And how do we write that? We write it like this. The B, then with an X there, the X component of vector B. And this is going to be, for us to get the X component of vector B, we multiply the size of vector B, which is 30 meters, multiplied by the cosine of the angle vector B makes with the positive x-axis. So if you look at the diagram we have here, this is our vector B in green. So the size of vector B is the 30 meters. That's where the 30 meters is coming from. And the angle vector B makes with the positive x-axis, that is the 120 degrees there. So 30 meters multiplied by the cosine of the angle 120 degrees, and this gives us minus 15 meters. So you notice something here. A component can actually have a negative sign, can have a minus sign. A component can have a minus sign, a component can have a positive sign. The negative sign here is telling you that this bx, the x component of B, which is minus 15 meters, is pointing in the negative x-axis. It's an x component. We're finding out how much it is along the x-axis, but because it's negative, it's pointing in this direction. So it lies along this negative x-axis. That's where components lie. Components lie along the axis. So it lies along the negative x-axis. That's what the negative is showing. Then by, so by is going to be the size of the vector, which is 30 meters, multiplied by the sine of the angle. The angle is 120 degrees. And this is approximately 26 meters. So you can see here that the size of the vector, the component by, is positive. If it's positive, since we're talking about the y component and it's positive, then it lies along the positive y-axis. So it lies along this line. Components always lie along an axis. It lies along this line. So it's positive. Then any questions on how to work out the components for B, Bx and By? Are there any questions? Okay. Next, we move on to vector C. For vector C, we have the size of vector C. Vector C is here. It's 10 meters. And the angle vector C makes with the positive x-axis from this side. As you can see, the angle is 180 degrees. That's how much vector C, that's the angle vector C makes with the positive x-axis. The angle theta is always measured from the positive x-axis in an anti-clockwise direction. So in our case, how much is vector C along the x-axis? That is what we call Cx. Cx is equal to the size of the vector. That is 10 meters multiplied by the cosine of the angle. The angle is 180 degrees. So 10 meters. Silva Kawe, can you switch off your microphone? Kawe, can you switch off your microphone? So Cx is going to be 10 meters multiplied by the cosine of the angle, which is 180 degrees. And if you carry out this multiplication, you end up with minus 10 meters. This minus 10 meters is, as you can see, it's minus, meaning that in the case of Cx, along the x-axis, it lies along the negative x-axis. But the other thing you notice is that the component is 10 meters, the size of the vector is 10 meters. So this is an example which shows that a component sometimes can actually have the same size as the vector. But most of the time, components have got a size which is less than a vector. Silver Kawe, can you switch off your microphone? Okay, so this example here with Cx, you can see that the component is 10 meters, the size of the vector is 10 meters. So it's actually possible that you can have a component of a vector having the same size as the vector. And most of the time, components have got a size which is less than the vector. What you don't have is a component having a size greater than a vector, because for components we always multiply them with cosine and sine, and cosine and sine have a maximum value of 1 and negative 1. So if cosine and sine had got a value which was more than 1 or negative 1, it would be possible for you to have a component which is greater than the vector. But since cosine and sine only go up to 1 and negative 1, it's not possible for you to have a component whose size is greater than the size of the vector. You can have a component which is equal to the vector, or a component which is less than a vector. So when a component is equal to a vector, what happens? Well, in this case, Cx is equal to 10 meters. Then what happens to Cy? Cy in this case is going to be equal to 10 meters sine 180, and that's what you get 0 there. So you get a 0. So if one side of the component is equal to the size of the vector, then the other side has to be 0. Are we clear on how we work out these components?
Yes, sir.
Okay.
I'm asking you, I'll send the request. Please accept me to join the meeting.
Okay. We have accepted the latest group. Okay. Next, why are we looking for components? We are looking for components because with each component, whether it's an x component or a y component, we know exactly in which direction a component is pointing. If we know exactly in which direction a component is pointing, then it becomes easy for us to add these vectors. So in the case of a plus b, when you're trying to add vector a plus b, what you actually do, this vector a plus b is a vector, a minus b is a vector, b minus a is a vector. Yes.
You said it could be less than when you find the component, it could be less than a vector or equal to. But is it okay when you find it more?
No, you can't find it more. You can't find it more. Because cosine and sine have a maximum value of 1 and negative 1. So if you're multiplying with something which has got a maximum value of 1 and negative 1.
And what about O?
Sorry?
Because bx, what about here? Because bx is giving us negative 15.
It's less than
yes.
negative 15. 15, the size is 15.
Oh.
And the vector has got a size of 30. So this is the 15 is the size. The negative shows you the direction in which the vector is pointing, the component is pointing. It's pointing along the negative x-axis. Are we clear?
Oh, okay.
The negative sign shows you which part of the xy plane your component is pointing. In this case, it's pointing in the negative x-axis. Yes. So the 15 is the size. Yeah.
Okay.
So a plus b, this is a vector. A minus b, this is going to give us a vector. B minus a is going to give us a vector. A plus b plus c is going to give us a vector. A plus B minus C is also going to give us a vector. When you're adding vectors or you're subtracting vectors, the question you're asking yourself is, this vector, how much is it along the x-axis and how much is it along the y-axis? So in the case of A plus B, you want to find out how much is A plus B along the x-axis and how much is A plus B along the y-axis. For you to answer the question of how much is A plus B along the x-axis and how much is A plus B along the y-axis, you add the components of the vectors involved in the addition. So we have vector A along the x-axis. The x component of vector A is 14 meters. Then the y component of vector B is minus 15 meters. So you're going to add here at ax, you're going to put 14 meters there, then plus, then at bx is minus 15 meters. Minus 15 meters. So it's going to be 14 meters plus minus 15 meters, and that's how you get your minus 1 meter. So the vector A plus B along the x-axis is minus 1 meter. So it's pointing in the negative x direction. Then the vector A plus B along the y-axis, you're going to add the components of A plus B along the y-axis. That is going to be AY. So AY is 14 meters and BY is 26 meters. So in this case, AY plus BY is going to be equals to 14 meters plus 26 meters, and that's going to give you 40 meters. So A plus B along the y-axis is 40 meters. It's positive, meaning that it's pointing along the positive y-axis. It lies along the positive y-axis. A plus B along the x-axis is negative, meaning that it lies along the negative x-axis. So for each operation of vectors, you need to find out how much is the vector along the x-axis, how much it is along the y-axis. Are we clear on how we have found out how much A plus B is along the x-axis and how much it is along the y-axis? Is this clear?
I have a question.
Yes.
Yes. I'm seeing with sorry, I came late with so I'm seeing like with 5 was 120. What means the factor? Meaning that you are collecting how are you finding the short angles?
How was I what?
How are you finding these angles?
These angles.
Example was 120, yes.
They're here. We just drew them. We said A is going to be 20 meters at 45 degrees. B is going to be 30 meters at 120 degrees. Then C is going to be 10 meters at 180 degrees. We just drew them. Yeah. Okay. Okay, then we move on to A minus B. So for us to A minus B is also a vector. So we want to find out how much is A minus B along the x-axis and how much is A minus B along the y-axis. A minus B along the x-axis is going to be AX minus BX. AX is 14 meters. Then minus BX is minus 15 meters. So what we have here is 14 meters minus 15 meters, and that gives us 29 meters. So A minus B along the x-axis is positive. It lies along the positive x-axis. Then we do A minus B along the y-axis. How much is it along the y-axis? It's going to be AY minus BY. AY is 14 meters and BY is 26 meters. So this is going to be 14 meters minus 26 meters, and that gives us minus 12 meters. So A minus B along the y-axis is minus 12 meters, meaning that it's pointing along the negative y-axis. Are we clear on this one? How much is A minus B along the x-axis? How we get the 29 meters? How much is A minus B along the y-axis, how we get the minus 12 meters. Are we clear?
Yes, sir, we are clear.
Okay, then we move on to b minus a. B minus a is also a vector. For any vector, you need to find out how much the vector is along the x-axis and how much it is along the y-axis. So in this case, for b minus a, along the x-axis, it's going to be bx minus ax. So bx is minus 15 meters, then ax is 14 meters. So in this case, it's going to be minus 15 meters minus 14 meters, and that's going to give us minus 29 meters. This is negative, meaning that b minus a along the x-axis is pointing in the negative x-axis. Because of the negative, it's pointing in the negative x-axis and has got a size of 29 meters. We also need to find out how much b minus a is along the y-axis. That's going to be by minus ay. So by is 26 meters, then ay is 14 meters. So we end up with 26 meters. So here 26 meters minus 14 meters, and we end up with 12 meters. This is positive. It's positive, showing us that along b minus a along the y-axis points in the positive y-axis. Are we clear so far with a plus b, a minus b, b minus a? On how we find out how much each of these vectors is along the x-axis and along the y-axis? Okay, you are not restricted to only adding or subtracting two vectors. You are not restricted to only adding or subtracting two vectors. You can add even more than two vectors. And that's what these two examples are showing at the bottom here, where you add three vectors. You add vector A plus B plus C. So we have A plus B plus C. This is also a vector. For this vector A plus B plus C, the question is, you want to find out how much it is along the x-axis and how much is A plus B plus C along the y-axis. So for the how much is this vector A plus B plus C along the x-axis, we get that by adding the components. That is going to be AX plus BX plus CX. So AX is 14 meters, BX is minus 15 meters, CX is minus 10 meters. So it's going to be here 14 meters plus minus 15 meters plus minus 10 meters, and we end up with minus 11 meters. So A plus B plus C, as much as we are doing addition, it points in the negative x-axis and has got a size of 11 meters. Next, we want to find out how much A plus B plus C is along the y-axis. So we do the addition, AY plus BY plus CY. So AY is 14 meters, BY is 26 meters, CY is 0 meters. So that's going to be 14 meters plus 26 meters plus 0 meters, and we end up with 40 meters. So A plus B plus C along the x-axis is minus 11 meters, meaning that it lies along the negative x-axis, and along the y-axis is plus 40 meters, meaning that it lies along the positive y-axis. You are not restricted to only adding vectors. You can do some addition, a combination of addition and subtraction. For example, here we put A plus B, then minus C. So the first two vectors are being added, then we subtract vector C. So in this case, this is also a vector. We want to find out how much this is along the x-axis and how much it is along the y-axis. So it's going to be AX plus BX minus CX. So AX is 14 meters, BX is minus 15 meters, CX is minus 10 meters. So it's going to be here 14 meters plus minus 15 meters minus 10 meters, and we end up with a size of 9 meters. So A plus B minus C along the x-axis has got a size of 9 meters. That's the x component of that. Then along the y-axis, it's going to be AY plus BY minus CY. AY is 14 meters. BY is 26 meters. Then minus CY, which is 0 here. So 14 meters plus 26 meters minus 0 meters, we end up with 14. So for all these vectors, we now have a very good idea. All these vectors we're doing, this A plus B, A minus B, B minus A plus B plus C, A plus B minus C. These vectors, when you add vectors or when you subtract vectors in whichever fashion or form, what you get is something called a resultant vector. When you add A plus B, A minus B, B minus A, what you get is a vector called a resultant vector. So when you add these resultant vectors like this A plus B, A minus B, B minus A plus B plus C, A plus B minus C, these are examples of resultant vectors. Vectors you get after you add or subtract your vectors. So for each of these resultant vectors, we know how much it is along the x-axis. We know how much it is along the y-axis. With this information, armed with this information, we can now proceed. Once you know how much a vector is along an axis, along the x-axis and along the y-axis, you can now proceed to find out how much is the size of that resultant vector, and also in what direction is the resultant vector pointing. So you can proceed to do that, and that's what we're going to do. So we're going to start with vector A plus B, and hopefully do these three by the time we are done. So for A plus B, along the x-axis, A plus B is 1 meter. And along the y-axis, it's 40 meters. So we use this information and we plot. We plot A plus B, which is what I'm trying to do here. Plot A plus B along the x-axis. Along the x-axis, this is my A plus B. It's minus 1 meter. AX plus BX, which is equal to minus 1 meter. It's negative 1 meters. So that's along the x-axis there. Usually, when you're drawing, when you're drawing, I think I'll have to improve on this diagram. When you are drawing a component on an XY plane, you have to draw it using dashed lines. Okay? So when you draw a component along an axis, you have to draw it using dashed lines, which I've not done here, but that's something to take note of. So along this x-axis, A plus B is minus 1 meter. Then along the y-axis here, A plus B is 40 meters. So what we want to find out is in which direction is A plus B. So what we're going to do, we're going to get this vector, this component, AY plus BY, which is 40 meters. We're going to get this component, then we put it at the end of this one, the AX plus BX, so that we can move along this line. Along the negative x-axis, we move minus 1 meter, then we move 40 meters along this dotted line, which is our AY plus BY, which is equal to 40 meters. We have not changed anything because the component AY plus BY is also a vector. Components are vectors. They are vectors whose direction we know precisely. So in this case, if you move AY plus BY, then you put it at the end of AX plus BX. You have not changed anything because the size of the vector is 240 meters and the direction is parallel to the y-axis. If the direction is parallel to the y-axis, then they are still pointing in the same direction. So components and vectors can be moved around as long as the size remains the same and the direction remains the same, then you haven't changed anything. Are we clear? You can move around the component as long as the size remains the same and the direction in which the component is pointing remains the same. it is still the same component. It is still the same vector. Are we clear? Okay. So,
Sir, can you please repeat that?
I am saying that we are going to shift this component AY plus BY, which is 40 meters and lies along the y-axis. This red line which lies along the y-axis. We shift this red line, then we put it at the end of this red line at the bottom along the x-axis, so that we can move like this, 1 meter minus 1 meter, then we can move 40 meters along that direction. The reason why we can do this is because, Genius, can you switch off your microphone? The reason why we can do this is because a component, your x component, your y component, is also a vector. Okay, we can do this shifting because a component is a special vector whose direction is known very, very well. In this case, when we shift this AY plus BY, we know that it points along the y-axis. So when we shift it so that it becomes parallel to the y-axis, we have not changed the direction. It's still pointing in the positive y-axis. It's parallel, yes, but it's still pointing in the positive y direction. And the size has not changed. So the size is still 40. So if the size of the vector hasn't changed and the direction of the vector hasn't changed, then we are still talking about the same vector. This allows us to move vectors around on an xy plane. As long as the size of the vector is the same and the direction in which the vector is pointing remains unchanged, the vector is still the same. So when we shift AY plus BY to this dotted line here, so that it occupies this dotted line here, this allows us to move along the x-axis like this, minus 1 meter. It also allows us to move along the y-axis by 40 meters so that we end up at this point. By ending up at this point, this is the same as starting from here on the origin, then we walk along this green line up to that point. This green line is your A plus B. This green line represents your resultant A plus B. Are we clear? That's how you have a rough location of where A plus B is, by shifting your y component so that your y component is located at the end of your x component. So that is your A plus B, this green line. So you can move like this, then you can move up like that. So you can move along the x-axis 1 meter, then you move up along the y-axis 40 meters, you end up at that point. You can achieve the same result by moving from the origin along this green line up to that point. This green line is your resultant A plus B. So now that we know roughly where A plus B is, the next task to do is we need to find the size of A plus B, because the resultant A plus B is a vector. For each vector you need to find the size, you also need to find the direction. For this A plus B, we know how much it is along the x-axis, it's minus 1 meter, this is what you have here. We also know how much it is along the y-axis, it's 40 meters. So that's what we proceed to do here. We need to find the magnitude of A plus B. So this, for A plus B, the magnitude of A plus B written like this is given by the square root of the x component of A plus B, which is AX plus BX squared, plus the y component of A plus B, which is AY plus BY squared. We know that the x component of A plus B is minus 1 meter, which is what you've put here. Then the y component of A plus B is 40 meters, which is what you've put there. So we end up with the size of A plus B equals to the square root of minus 1 meter squared plus 40 meters squared. And that gives us, when you do the calculation inside here, end up with 1601 meters squared. Then if you square root that, you end up with A plus B being approximately equals to 40 meters. So that is the size of A plus B. It is approximately equals to 40 meters. So this A plus B you're seeing here, we now have a solid number. What is its size? it is approximately 40 meters. Next is we need to find the direction of the resultant A plus B. Now, for you to find the direction of the resultant A plus B, what you're looking for is this angle, theta. For any vector, you measure the angle from the positive x-axis. From this positive x-axis, you measure from the positive x-axis all the way up to where that vector is. So the angle you're looking for is this one, theta. However, with the information which we have, the x component, which is minus 1 meters, located this side, and the y component, which is 40 meters, located here or there, it is not possible for us to directly find this angle, theta. Okay? Instead, we do something else. If you look at this side here, which is your x component, ax plus bx, which is minus 1 meter, then you look at this dotted line, which is your ay plus by, which is 40 meters, then you look at this green line. What you end up seeing is that you have yourself a triangle. You have this triangle. Can you see it?
Yes.
Yes, you have this triangle. Now this triangle, inside this triangle, there is this angle here, which starts from the negative x-axis, then goes in reverse, goes clockwise. So from the negative x-axis up to where the vector, the green vector is there. This angle is phi. Okay? Now, remember what we said about angles. Angles are always measured from the positive x-axis. Angles are measured from the angle theta is measured from the positive x-axis in an anti-clockwise direction, so it's positive. Now, if you measure an angle from the negative x-axis or from any axis, if you measure an angle from any axis, either negative x or positive x, then you go in a clockwise direction, then that angle is going to be negative. So angles which are measured in a clockwise direction are negative. So as we are measuring this angle phi from this negative x-axis, then we're going like that. We know that this negative x-axis is 180 degrees. So we are measuring 180 degrees, then we are going back in reverse. So whatever we're going to get for this phi, then we add it to 180 degrees, it should give us theta. So we'll try to work out this angle inside the triangle, which is phi. Then when you get this angle phi, it's going to be negative because it's going in a clockwise direction. Then we're going to add it to the 180 degrees because we know how much this axis is. The negative x-axis is always 180 degrees. So we have phi, then we add it to 180 degrees. That should give us theta. So that is how we're going to find our theta. We're going to find our theta indirectly through phi. Are we clear?
Yes.
Okay, so we work out, because with phi we can, this is now the adjacent, that is opposite, so we can use that tan relationship. So we can say tan phi is equals to the opposite is ay plus by, then the adjacent is ax plus bx. So this is going to be the ay plus by is 40 meters, then divided minus 1 meter. This is going to give us minus 40. Then we work out the phi is going to be the tan inverse. So tan inverse of minus 40, and this gives us a phi which is approximately equals to minus 89 degrees. Your phi is negative. The reason why phi is negative is because you are measuring phi in a clockwise direction. Angles are measured in an anti-clockwise direction, and they're positive in the anti-clockwise direction. So if you measure your angle in a clockwise direction, then it's going to have a negative sign. Are we clear? Is this clear?
Yes.
So our phi is negative 89 degrees, and we measured our phi from the negative x-axis. So this negative 89 degrees, we're going to add it to the negative x-axis so that we can get our theta. So our theta is going to be equals to 180 degrees plus phi, which is going to be equals to 180 degrees plus negative 89 degrees, and that's going to give us a theta which is equals to 90 degrees. Our theta is now positive because we are measuring theta from this side, from the positive x-axis, then we are going in an anti-clockwise direction. So with that, we find for a plus b a precise value, size. The size of a plus b is approximately 40 meters, and the angle a plus b makes with the positive x-axis is 91 degrees. Are we clear on how we have done this?
Yes, but I have a question.
Yes. Go ahead.
Like for the calculations, I always supposed to round off the answers to the nearest one number or to be specified.
The final thing can be rounded off. You don't have to go to so many decimal places. Right. We don't need that. Okay. Next.
Always the whole number.
I don't know what you mean rounding off to a whole number very much, because I don't think that's what we have done that. What have we done? Here in this case, it just happens that I'm rounding off I decided, I made a choice of rounding off to a whole number. So you can do something similar, because remember in physics you are estimating things. So what you're doing are estimations really. So if that's what you want to do, fine. Okay. So we move on to this one, a minus b. For a minus b, we know the components. How much is a minus b along the x-axis? A minus b is 29 meters. Along the
your question.
Yes.
I didn't get you properly on that one where you are saying that the angle, when it's in you are calculating in clockwise direction, you have to add.
No, when the angle is in a clockwise direction, it's negative. In a clockwise direction, the angle is negative. Look at these two angles. There's this phi. They are pointing. We're measuring them in different directions. This one is clockwise. This other one is anti-clockwise. By definition, our angles are only measured in a clockwise direction, in an anti-clockwise direction, and in that anti-clockwise direction, they are positive. So all angles measured in an anti-clockwise direction are positive. So using that definition, this angle phi is in a clockwise direction. So that's why it comes out negative.
So then why are you adding to 180 instead of subtracting, since going in a clockwise direction?
I know that this thing is 180, right?
Yes, sir.
I know that this thing is 180. But this angle is negative. What I did is I added. So to a 180, I added this angle. That's what I do here. Here, 180 plus phi. That's what I do. I added. Yeah, it just turns out that the phi is negative. So you have 180 plus negative 89. Then that's how I get the 91.
Thank you, sir.
All right. Any other questions? Okay, so let's see if we can quickly go through this one. So a minus b. So for a minus b, we know that the size of a minus b along the x-axis is 29 meters, then along the y-axis is minus 12 meters. So using this information, we can find out how much a minus b is. So that's going to be, this is along the x-axis, along the y-axis, so the square root of the x component, and the squared plus the square root of the y component, that, so you end up with this square root 29 meters squared plus minus 12 meters squared, and that gives us 985 meters squared. Then you do the square root of that, so you end up with a minus b being approximately equals to 31.4 meters. So that is the size of a minus b. Okay, if you make a plot along the x-axis 29 meters, along the y-axis minus 12 meters, if you make a plot of this, what you get is this here. So along the x-axis here, ax minus bx are 29 meters. That is the x component of a minus b. Then along the y-axis you have this, ay minus by minus 12 meters. So along the y-axis it's minus 12 meters. Along the x-axis is 29 meters. Like that. So the angle you are interested in. So after this, again, we get this y component. We shift this y component. We put it at the end of the x component so that we move like this. We move 29 meters along the x-axis. Then we move minus 12 meters along the y-axis. We end up here. So you moving from here, there, up to there, this is the same as moving from the origin here up to this point. This green line is your resultant a minus b. So this is where a minus b is located. We have found the size of a minus b. The next thing we need to find is the angle a minus b makes with the x-axis. And that angle is always measured from the positive x-axis. Then we go in an anti-clockwise direction like that. So the angle we are looking for is this theta outside, measured from the positive x-axis anti-clockwise all the way up to here. Again, the problem is you cannot get theta directly from the 29 meters and the minus 12 meters the way things are. However, you realize that if you move along this side to minus 29 meters, you look along that side minus 12 meters, and we know what this vector is here. This size is here. We have just found it. You have a triangle, an upside down triangle. This upside down triangle, inside this triangle, there is this angle phi. This angle phi is measured from the positive x-axis, this side, then we move in in a clockwise direction. So you're measuring from there like this. So you're going in reverse from what theta is doing, like that. So once we find this phi, we are going to add this phi to 360 degrees so that we can find our theta. Are we clear? Are we clear on that? We find the phi inside the triangle. Then after we find the phi, we are going to add it to 360 degrees so that we can find our theta. And that's what we do here. So tan phi is equals to ay minus by divided by ax minus bx. Ay minus by is 12 meters. Then the ax minus bx is minus 29 meters. So we end up with minus 0.41. Then phi is going to be equals to tan inverse of minus 0.41. Like that. Then you work out phi comes out to be minus 22.3 degrees. It is negative. The reason why it's negative is because phi is measured from the positive x-axis going in the clockwise direction. Any angle measured in a clockwise direction is negative. Now that we have our phi, we add it to 360 degrees. So for us to get theta, it's going to be 360 degrees plus phi. So that should be 360 degrees plus minus 22.3, and that gives us a theta of 337.8 degrees. Are we clear?
Yes.
Yeah. So we have to come to an end here. I have to rush. I'm still at home. So I have to get to campus in the next hour. I've got another class at 10. Okay, so if there are any other questions, we have to reserve those questions for next time we meet on Monday. Let's hope there is no holiday on Monday. Is there a holiday on Monday?
I don't think so.
Okay, so let's reserve that for the holiday on Monday if there are any questions. I need to rush. Okay.